So in our next chapter, we are going to talk about maps from the class 6 geography NCERT. Yeah, it's chapter 4. Yeah, definitely we're going to look at syllabus categorization and relevance. So this topic falls directly under the following core components of the Civil Service Examination UPSC syllabus: GS Paper 1 Geography and GS Paper 3 Science and Technology. In GS Paper 1 Geography, we have to understand basics of geomorphology, cartography, and Earth's spatial representation. And in second point are like important geophysical features in their location. So that comes under the GS Paper 1 Geography topic, and under which that we had to understand maps. In GS Paper 3, we had to understand geospatial technology, space-based remote sensing, and digital public infrastructure (DPI). So we are going to understand like this topic falls under these two broad categories. Now, we are going to talk about foundational concepts: globe versus map. What is the difference between globe and a map? Understanding the transition from the three-dimensional planetary models to two-dimensional cartographic planes is essential for spatial analysis. Transition जब होता है थ्री डायमेंशनल प्लेनेटरी मॉडल्स टू टू डायमेंशनल कार्टोग्राफिक planes is essential for spatial analysis. So when we have to understand a spatial places, a spatial when you want to make analysis of spatial, then we have to go from 3D planetary model to two-dimensional 2D cartographic planes like maps. Comparative analysis matrix: the globe and the map. Globe basically a spherical representation of Earth, while highly accurate for studying the planet as a whole. It poses several functional limitations. It cannot provide detailed localized views and is of little help when analyzing specific subnational units like a country, state, district, town, or village. The map basically a flat mathematical representation or drawing of Earth's surface, okay, or a specific portion of it rendered according to a precise scale. Map basically flat mathematical representation or drawing of the earth's surface or a specific portion of it rendered according to precise scale. Maps deliver significantly more detailed information than a globe for localized regions. The geodetic paradox: it is mathematically and physically impossible to flatten a round 3D shape completely on a 2D plane without introducing distortions in area, shape, distance, or direction. Next one, scalability and compilation. Compilation scalability, okay? What is it? Data density. Data density variation. What is it actually? Maps are highly customizable. We know about that, like we can customize map as per our need. A single map can be simplified to show only a small area and a few basic facts, or conversely, it can pack as much dense information as an entire textbook. The atlas: when multiple sheets of maps are compiled, bound, and systematic measurements are drawn across varying dimensions and scales, they form an atlas. Next one, typology of map. So we are going to talk about typology of maps. Maps are systematically classified into three dominant functional categories depending on the nature of the information they prioritize. So they have physical or relief maps, political maps, thematic maps. These are the three classification of maps. Okay, physical or relief maps like special drawings, okay, explicitly dedicated to showcasing the natural physiographic features of the earth. These include landforms and water bodies such as mountains, plains, rivers, and oceans. Political maps: cartographic layouts detailing human-centric administrative configuration. They indicate exact boundaries separating different countries, states, cities, towns, and villages. Thematic maps: highly specialized maps that disregard general boundaries or relief features to focus entirely on a specific dataset or type of information. Examples include road network, rainfall distribution layout, industrial wells, and forest coverage maps. They require clear, descriptive titles based directly on the dataset they represent. Next, we have the three core components of a map. Three core components. Every mathematically valid maps relies on three structural core pillars: distance, direction, and symbol. So every mathematically valid maps relies on three structural core pillars: distance, direction, and symbol. Component A, distance and scale mechanics. Okay, so we have to understand scale mechanics under the distance. So maps are essentially compressed drawings that carefully scale down the real world to fit onto a physical page or a digital display. To keep the represented layout accurate, map makers choose a specific mathematical scale. Maps are essentially compressed drawings that carefully scale down the real world to fit onto a physical page or digital display. To keep the represented layout accurate, map maker choose a specific mathematical scale. Scale is equal to scale is equal to scale is equal to actual distance on the ground upon represented distance on the map. That's what is scale. Next, okay, component distance and scale, and we have mathematical mechanics and empirical example. If the real world distance between an individual's home and school is 10 kilometer, and this span is drawn as 2 centimeter on paper, so the map's scale factor is calculated is equal to 1 centimeter is equal to 5 kilometer, so 2 centimeter is equal to 10 kilometer. You understand? So knowing this ratio will allows an analyst to determine the precise real world distance between any two coordinates on that map. Scale classification framework. Scale typology. Typology means a classification. Okay, small scale map, large scale map. Scale typology: operational metric, spatial coverage, information density. Small scale map: 5 centimeter on paper, 500 kilometer on actual ground. Large scale map: 5 centimeter on paper, 500 meters on the actual ground. Okay, small scale, large scale. Small scale map: massive area like whole continent, hemispheres, or sovereign countries. Whereas large scale map: highly localized settings like a village, urban, or water town. Small scale map: information density, broad information, generalized data, overviews. Large scale map: exceptionally high information, deep density, and deep information density. Next component is direction and orientation framework. First component was distance and scale. Okay, distance. Second one is direction, and third would be distance, direction, and symbol. Okay, there's a symbol. Wait, yeah, third one would be symbol. Okay, so second we are going to cover direction and orientation framework. Direction: the north line, cardinal points, intermediate direction, and a magnetic compass. The north line. Standard maps features an arrow pointing toward the upper right corner accompanied by the letter N. This indicator serves as the base reference line for the determining all other secondary directions. Cardinal points: the four primary direction: vertical north, south, east, and west. Vertices: north, south, east, and west. Four cardinal points: the four primary directional vertices: north, south, east, west. Cardinal points. Intermediate direction: the four secondary compass vectors that allow for more precise mapping: northeast, southeast, southwest, northwest. The magnetic compass: a mechanical instrument utilized to find the primary direction in the field. Its internalized magnetic needle always aligns directly along the Earth's north-south axis. Component C, that's a symbol and spatial language. Symbols allow map makers to legibly compress real-world infrastructure like roads, bridges, railway tracks, structures, and trees into a limited layout. They compress extensive information into clean, scannable format using distinct letters, color codes, textures, and lines. Universal cartographic language. To bypass language barriers and ensure global readability, international agreements standardize these markers. These are called conventional symbols. These are called conventional symbols. Universal cartographic language to bypass language barriers, ensure global readability, international agreements standardize these markets. These are called conventional symbols. A standardized color matrix. Blue for water bodies and oceanic system. Brown for mountain range and high altitude relief. Okay. Yellow for plains and elevated tabular landforms. Green for lowered plains and agricultural valleys. Next we have alternative spatial models, sketches versus plans. Somewhere we are not able to we are not able, I mean sometimes we don't have a maps, or we don't have global maps like that. So in that condition we have some alternatives like sketches and planes, okay, but we have to find difference. Sketch versus plans, what are the difference between those? When standard maps are too detailed or not structured for a specific task, a special information is categorized into alternative models. The sketch map and the plane V, then they come there. Okay, sketch map basically a rough drawing based on immediate memory and on the spot observation. It completely lacks a calculated scale. Its primary function is to show where a specific location sits relative to nearby landmark. Its primary function to show where a specific location sits relatively to nearby landmarks, like a friend drawing an unskilled guide map to help you find their house. The plan, a highly accurate drawing of a small area rendered on an exceptionally large scale. Plans display specific micro measurements that standard maps omit, so the exact internal length and breadth of an architectural room. Next, we have contemporary institutional development media 2026. So, what are the contemporary institutional development? To meet UPSC requirements, foundational cartographic principles must be connected directly to India's expanding digital governance framework. The National Geospatial Mission (NGM) strategic allocation. In the Union Budget, central government launched the National Geospatial Mission with an initial allocation of 100 crore. This mission operationalized the core tenets of the National Geospatial Policy to transition India from static mapping to real-time data-driven spatial governance. The National Geospatial Mission (NGM) strategic allocation. In the Union Budget, central government launched a National Geospatial Mission with an initial allocation of 100 crore. This mission operationalizes the core tenets of the National Geospatial Policy to transition India from static mapping to real-time data-driven spatial governance. Core administrative objectives. The initiative prioritized modernizing land records, upgrading urban local body infrastructure, and creating a unified digital mapping framework to resolve long-standing land disputes. Next, we have high resolution mapping infrastructure, Naksha program, course network, and National Digital Twin Goal. Naksha program standing for National Geospatial Knowledge Based Land Survey of Union Habitation. This initiative modernizes urban land records using drone surveys and global navigation satellite GNSS. It builds highly accurate, large scale GIS database across hundreds of urban local bodies globally. The Naksha program standing for National Geospatial Knowledge Based Land Survey of Urban Habitations. This initiative modernizes urban land records using drone surveys and global navigation system GNSS. It builds highly accurate large scale GIS database across hundreds of urban local bodies. The course network run by the Survey of India course. Okay, Survey of India run करता है इसको. The country's principal mapping agency, Survey of India principal mapping agency है, continuously operating reference stations framework deliver precise real-time positioning data within a millimeter level accuracy threshold. This system underpins precision agriculture infrastructure planning and disaster risk management. National Digital Twin Goal, Digital Elevation Model DAM. National Digital Twin Goal. The Survey of India is actively working toward its policy target. generating a high resolution digital elevation model DEM for the entire country by 2030, alongside comprehensive 3D digital twins for major urban centers by 2035. So this chapter is also going to be end, and I hope you understand. अगर समझने you can watch it again, and I hope you like it.